Carbon. Carbon is the centerpiece. It is the main player. It is the star of the carbon cycle, hence the name. So before we can even really talk a lot about the carbon cycle itself, I have to do a little bit of justice to carbon. Now I know what you're thinking, oh, carbon, boring. But actually there's some really cool facts about carbon. So let's talk about those facts really quickly. First off, carbon is actually the fourth most abundant element in the entire universe. So think about all of the different chemicals and components of our entire universe. Carbon ranks number 4 on the most abundant, meaning that if I were to make a list of what the universe is mostly made up of, carbon would be number 4. So obviously, it's a pretty present, pretty important element. Now, that being said, it plays an even bigger role for us because not only is carbon the fourth most abundant element in the universe, it is literally the building block of life. Every single one of your cells, the food that you eat, the energy that you get, the stuff that you breathe out are all made up to some degree of carbon. And that is the truth for every single life form here on Earth. We are a carbon-based species, meaning that everything from our DNA to our mitochondria, which by the way, that's the powerhouse of the cell, to our hair follicles, to everything, to the foods we eat again, have carbon in them. In fact, for something to even be considered organic, one of the big prerequisites is that it has to have carbon in it. So carbon is not just a very abundant element in the universe, it is literally the most important element in life. In life. Including DNA, fossil fuels, so DNA, fossil fuels, the sugars that you eat, the fats that you eat, the proteins, those all have carbon in them. And when you eat food or you breathe out carbon dioxide, those are actually exchanges between us as humans and other components of the Earth system. Through carbon cycles, through all kinds of components, through land, through life, also known as the biosphere. In fact, let me write that down here. Through land, life, the biosphere, the ocean, the atmosphere, and then other components of the solid Earth. So carbon is at play everywhere on Earth. We can find carbon in all living things, in our atmosphere, in layers of limestone, in the crust of our planet. We can find it on the bling on our rings, on our fingers. We can find carbon in a lot of different places. And in fossil fuels like coal. Coal, this gentleman right here, is basically one giant lump of carbon. One giant lump of carbon. Now, where do we find carbon? It exists in our atmosphere, specifically in the forms of carbon dioxide and methane. In life, as I mentioned, carbon, sugar, protein, fats, all have carbon in them. In our soils, methane is actually stored up in our soils, and just some elemental carbon is also stored up in our soils. In our oceans have a lot of dissolved carbon dioxide in them. Now, there's one thing I'll mention about this really, really quickly, just because I want to make sure I do it justice. Very similar to when a glass of water absorbs carbon dioxide and it becomes sort of fizzy and carbonated. The same thing literally happens to our oceans. As carbon dioxide dissolves into our oceans, it actually makes our oceans slightly acidic, makes them slightly acidic. Yes, I'm literally saying that carbon dioxide actually acidifies our oceans. Um, and as more carbon dioxide is present in our atmosphere, that means that more is being dissolved in our oceans, and our oceans are actually becoming more acidic. Now, that doesn't mean that you're going to melt if you go for a swim, but there are some organisms that are really, really, really sensitive to the acidity of the ocean. And so they can actually start to experience health problems, dissolving of their shells, dissolving of their skin. So it can actually start to look pretty bad. So, that being said, where is the most carbon on our planet? Well, the fact of the matter is, the bulk of carbon here on Earth is actually found deep in our oceans. In fact, 81% of all of the carbon on Earth is actually locked up in the deep ocean. Now, that might make you think, okay, well, everything else is insignificant. Well, that still means that there's 18% elsewhere. And that 18% is constantly moving around and constantly changing. And where it ends up actually has major implications for life. 1.6% or 750 gigatons is in the atmosphere, 1.3% in vegetation, 3.4% in soils, 2.17 or so 2.2-ish% if you round up in our surface oceans. Not a whole lot in marine life. A little bit in sediments, and then a giant amount actually. In fact, the second biggest source of carbon on Earth, other than our deep oceans, is actually found in fossil fuels and in cement. And cement's actually made up of quite a bit up of fossil fuels. So, all things considered, fossil fuels are actually a big carbon source here on Earth. Now, with that said, one thing I want to say about carbon really quickly is the idea of what's called carbon conservation. So, it is believed, and there's a lot of data and a lot of observations to back this up, that the carbon that is present on our planet now, including the carbon that makes up your body, was here when Earth formed. Meaning that those planetesimals, whether they were homogeneous or heterogeneous from a few weeks ago, when they all came together, the carbon that we are right now came on those planetesimals. And carbon really doesn't increase or decrease globally. What this means is that we're not, as a planet, exchanging a lot of carbon with our neighbors, with outer space, with anything outside of the planet. This is what is referred to as the law of carbon conservation. Carbon is not created, it's not destroyed, it's not taken away from the earth, it's not added to the earth. Now, that being said, there are some exceptions to this. When you launch something off into space, if you launch a chemical rocket or anything like that, there might be a little bit of carbon involved in that. But that is so negligible compared to how much carbon is present here on Earth that it is essentially a non-issue. It is basically like what a dime is to a trillionaire. It's like nothing. And so any flows of carbon into and out of our planet really don't matter. They're too small, they're too insignificant, they're not even in the margin of error. So we don't worry about them. So the idea of carbon conservation is that carbon does not increase or decrease globally. Instead, carbon moves throughout the different components of our Earth system. So there was once a time when our atmosphere had a lot of carbon in it. It was an extremely carbon-rich atmosphere. When the Earth first came to be, Earth's atmosphere was very, very carbon-rich. And then a ton of these little things called cyanobacteria came on, and they took all that carbon out of the atmosphere and into their little cyanobacteria bodies. That is an exchange between the atmosphere and life. And so carbon is exchanged between all these different components of the Earth system. That being said, in a moment, we'll actually talk about these different components of the Earth system and their roles in the carbon cycle.